Right, this is 3.8. This is analyzing graphs of polynomial functions. So there's two major skills I want you to take away from this section. And that is, first of all, how to sketch a graph provided an equation in factored form. So again, notice in that first example, it's already factored down for you. So here's what I want to be able to see clearly on this graph. I want to be able to see the zeros of the function. So again, remembering to find the zeros, all you do is you change the sign of what's in the parentheses. So again, if we were to set this equal to 0, we'd have to subtract 3 from both sides, which is why we'd have a 0 at -3. Changing the sign of -2 would become +2. So right there is another one of our zeros. And changing the sign of -4 would be +4. The next thing I'd want to see is the appropriate end behavior. So for this, you'd have to understand how to determine the degree and the leading coefficient. The leading coefficient would be determined by multiplying this number, which is 1, by all of the leading coefficients of the x's, which in this case is all 1. So my leading coefficient is actually +1. And again, remember that our leading coefficients are considered either positive or negative. And for the most part, these ones are going to be positive. To find the degree, I'm going to erase what I just circled so that you can clearly see how we find the degree. To find the degree, we're going to add. Okay, so what we're adding the exponents of my factors. So this is a 2, this is an invisible 1, and this is an invisible 1. Okay, so we're going to have 2 plus 1 plus 1, so my degree is 4. And remember, our degrees are considered even or odd. Okay, so 4 is even. So here's what we know about what's happening on the right-hand side of the graph. It's going to go up. And that's because it's positive. The leading coefficient tells us the right-hand side of the graph. The degree tells us what happens on the left-hand side. Remember that even means they're doing the same thing. Now the third part, we want to see the y-intercept. And here's how you're going to find the y-intercept. You're going to take this 3 and you're going to square it because it's the 2. The 2 has the exponent right there. So you're going to take 3 squared. You're going to multiply that by -2, and you're going to multiply that by -4. And if there was a number out in the front, you would multiply this by that number as well. Okay, so 3 squared is 9. That is +8. So my y-intercept is 72. Okay, and again, I don't really care about the scale of your graph. If you want to make this go by, I don't know, 12s, 1, 2, 3, 4, 5, 6. Okay, so 72 would be way up there. Okay. And the only other thing I care about is that the intervals of the graph are in the appropriate area. So keep in mind, your graph can only cross the x-axis, okay, at these red dots. Okay. Your graph can't cross at any other point, otherwise they'd be zeros. And we don't have any other zeros of this function. So here's what I know about this. Okay, I might not know how high it goes. It might go higher on this side or higher on this side. We are not doing local minimums and local maximums. So again, it's going to go up and then it's going to go down. Okay, I'll show you a second way to figure out this second part in a second. So what I might want to know what my graph is doing over here. And again, the graph is either above the x-axis or below the x-axis. So all I need to do is plug 3 into that equation, which is going to require me to pull out my calculator. So 3 plus 3 n parentheses squared. Parentheses 3 minus 2 n parentheses, parentheses 3 minus 4 n parentheses. And when I hit equals, I get -36. So again, I'm going to label this point as 72. All right, and again, I don't really care that how far your graph goes down. Okay. So the second way of figuring this out is something called multiplicities. Okay, so I'll explain that. So again, if it's easy for you to just plug things in and figure out is it above or below the graph, and again, I went below the graph because it was negative. Oops, because it was negative. Okay. Multiplicities are based on evens and odds. So again, notice right here, we have a multiplicity of 2. 2 is even, and even multiplicity tells me that once you hit that 0, you don't cross, you bounce. So notice it goes down, it hits that -3, and then it bounces and it goes back up. It doesn't cross the y-axis, x-axis. It doesn't cross the x-axis. Okay? Notice here, this is -2. It has a multiplicity of 1. 1 is odd. Odd tells me we're going to cross. So when we're traveling back down to the 0, which is at 2, we're going to cross the x-axis. Okay? Right here we have another multiplicity of 1. So if there's not a number, there's an invisible 1. And again, 1 is odd, which means when we travel back up to the 4, we have to cross. Okay? So even bounces, odd crosses. Okay? I'm going to show you a second example of this stuff. Okay? So again, we have 3 zeros that should be plotted on my axis. So I have a 0 that should be at 2. I have a 0 that should be at -1. And I have a 0 that should be at +5. So 2, 5, -1. Those are all my zeros. So again, looking at end behavior, okay, my leading coefficient is still 1 because again, 1 times 1 times 1 times 1 would be 1. And again, our leading coefficient is almost always positive in these. So again, that's positive. And again, this tells me something very specific about the right-hand side of my graph, and that's that it goes up forever and ever and ever. My left-hand side of the graph is based on degree. So again, degree, you have to pull out your fingers and be able to add, or just know mental math. We have 2, and over here there's an invisible 1. So don't forget the invisibles. Okay, your degree is 5. Okay, and remember our degrees are even or odd, and 5 is odd. And again, the fact that it's odd tells me that over here on the left-hand side, once we get to the left-hand 0, we're going to go down. Okay. Now, if you were paying attention to what I was talking about bouncing and crossing, okay, this 0 has a multiplicity of 2. Okay, so that's even. So again, one other thing I do want to see reflected on your graph is the y-intercept. So let's go ahead and figure that out really quick. You're going to have -2, and you're going to square it because the factor that has -2 in it is squared. You're going to have 1, and you're going to square it, which is going to make 0 difference whatsoever because 1 squared is still 1. And you're going to have -5. Okay, so notice this is just the back end raised to the power of the parenthesis. So that would be 4 times 1 times -5. That is -20. And again, I don't care what you put the scale on this graph. If you want this to be 5, 10, 15, 20, I have no qualms whatsoever. So again, I'd label it just so that I know that you know where the y-intercept is. Okay, so again, at -1, multiplicity is 2, which means when we get to 1, we're going to bounce off. And again, we're going to know that we bounce off because my y-intercept is at -20. Okay, now we're going to travel back up to the 2. And again, I'm not worried about local minimums and local maximums. I'm not worried about any of that stuff. I just want you to be able to sketch me the most basic of graphs. Okay, so then when we look at the 2, okay, notice that one has a multiplicity of 2. So again, what that means is once we hit the 2, even bounces. So it's going to go back down. And again, I don't know how high or low. I'm not overly concerned with this graph being super accurate. I'm just concerned that this graph has the same amount of turning points that it needs. So again, it should turn here, go back down. It should turn to go back up. It should turn to go back down. And again, it should cross at 5 because the multiplicity is odd. So again, it crosses at the odd. It bounces off the evens. We have our y-intercept represented right here. And our end behavior does exactly what it's supposed to do. So again, if you don't like this method, you can always just create a table of values. So put your 3 zeros or 4 zeros or 5 zeros or however many zeros the problem has. You could always just have created a table of values. So you'd want 1 to the left of the green dot of this 0 right here at -1. So to the left, you might pick -2. You could pick -3. You could pick -4. I would pick -2 just because it's closest. Okay. You'd want 1 dot in between -1 and 2. So you might pick 0 or you might pick 1, or you should obviously pick 0 because I want to see the y-intercept. You pick one dot between 2 and 5, so pick 3 or 4. I'd pick 3 just because it's smaller than 4. And then you'd want to know what's happening to the right-hand side of your graph. So again, a number past 5, and again, if I'm doing it, I'd pick 6 just because it's the number right next to 5. So again, what I promise you is if you were to plug -2 in here, what you're going to get a negative number, which tells me I should be below the x-axis. When you plug in 0, I promise you'd get -20 because we've already done that. When you plug in 3, what I can promise you is you get a negative number. And oops, when I plug in 6, I would get a positive number. Okay, so again, all I'm asking you to do is to sketch these graphs. I don't need it to be super specific. Okay, so on a test, so those are the things that I'm looking for. All right, finally, we're going to determine whether functions are even or odd, and this is really fast. Okay, so an even function is symmetrical about the y-axis. So we fold it on the y-axis, the left side matches the right side. So our parent function parabolas and our 4th degrees and our 6th degrees all display this even function symmetricalness. An odd function is symmetrical about the origin, which means if you took your paper and you flipped it upside down, it would look exactly the same as it does right side up. There's 2 ways of determining whether a function is even or odd. So the first way, we're going to plug in negative x every time that we see x. Okay, so negative x cubed, well, 3 is odd, so that means it keeps the negative. So this becomes negative 5x cubed. 2 is even, so again, I'm talking about this 2, not the front 2. So remember, if we square a negative, it becomes positive, because a negative times a negative is positive. So this right here is going to be plus 2x squared. And the -1, we don't have any x's, we don't have to do anything with it. So does it look exactly the same as it started? No, because this was positive and now it's negative. Okay, did all of the signs switch? Again, no, because this is positive, so the sign didn't switch either. Okay, neither did the back term. If neither one of those is true, then this is neither even or odd. Neither, however you want to pronounce that word. Okay, so again with this one, we have 3 negative x to the 4th minus 2 negative x squared plus 10. So again, because a negative is being raised to an even power, the negative disappears. And if the negative disappears, that means that's going to become 3x to the 4th. Okay? Same thing with this one. Negative x squared would be positive x squared because negative x times negative x is positive x squared, which would be multiplied by -2, which would get us negative 2x squared. And then plus 10 doesn't have an x. Okay? So does the function look exactly the same after being simplified? Look at that, it does. 3x to the 4th minus 2x squared plus 10. This is an example of an even function. Okay, and finally down here, so if I have 10 negative x to the 5th minus 3 negative x cubed plus 5. Okay, so again, if I raise a negative to an odd power, it becomes negative because a negative times a negative times a negative, 5 times it just becomes negative. So the negative is going to affect the 10. It's going to change the sign of the 10. So again, this right here is also odd. So the negative is going to change the -3 to a +3. And then the 5 is going to come hang out at the very, very end. Okay, so does it look exactly the same? No. This one's negative, this one's now positive. Did they all change? No, because the 5 is still positive and the 5 is still positive. So again, this one's neither. All right, so now I'm going to show you the shorter way, the way that I like to do it. Okay, what you're going to look at is the degrees. So if all of the degrees are even, so remember that 0 is an even number. And I can explain to you why in a separate time. Okay, if all of the degrees are even, the function is even. If all of the degrees are odd, and again, that means it can't have a constant, just a number, then the function is odd. If it includes both even and odd exponents, then it's neither. So again, this is 7, this is 3, this is 1. Those are all odd. This is an odd function. This is 9, this is 8. It includes both even and odd, so this is neither. This is an 8. This is a 4. This one has a degree of 0. So this one is even. So you see how that way is so much easier to me. That's why I do it that way.